Hello everyone and welcome to my channel. Today we are here to see the first machining operation, which is the boring. So let's go immediately in machining and let's start from the top. So boring, we select it, and at this point the first thing on the right panel, the first thing we see is that this machining can be applied from the geometry or from the position. So if you are working with a drawing, maybe because you have imported the drawing, the XF, and you want to just apply the machining to that geometry, of course you will select from geometry. Otherwise we can go by position. And so if we select by position, first of all, here we have our panel exploded. So 0 is the top face, 1, 2, 3, 4 are the sides, and the fifth one is the bottom. As you can see, by default I have the top left corner as a reference corner. And let me immediately say that if the same coordinates are also taken from the other corners, it's basically simple as that. So just enable also all the others and it will be done. Of course, if you want to make an horizontal boring, an horizontal drilling, you just need to select a reference corner of the side face, any of the side face, or even, more than one. Of course, the coordinates now are completely wrong for the horizontal because, so let me turn off maybe the top, because in case of the horizontal machining, let's focus only on one of them, our X will become this one and our Y will become this. So X and Y. Just to see it more clearly. If we use the face selection, because right now the top face is the one selected, and you can immediately notice it because you can see the reference corner and the axis. So the X axis will be here and Y here. Let's see what happens when we select a different face. Okay, see? Now, this is my X and this is the Y. That's why my 100 goes down here. So if we go back in the machining and in the Y position, we specify LPZ divided by 2. And for all the people that didn't see my video of the parametric programming yet, LPZ stands for length of the panel along the z-axis, which is the thickness, and it will stay always the thickness of the panel. In this case, I said, okay, let's place the coordinate at half of the thickness, so centered along the thickness. Of course, the next really important thing is the tool. So which one is the tool we want to use for this hole? And you have two options. It can be by diameter, so you just have to specify diameter and depth, and eventually the tool type. So here you have all the options. Otherwise, you can just simply select tool and you can choose the tool directly from the library. And as you can see, I also have router bits. Why I'm able to see router bits here? Just because these router bits, whenever we were creating the tool, have been enabled also for drilling. That's why I'm able to select them, because here you will only see the part of the library related to drilling. The green dot on the top right corner, remember, that is telling you that the tool is tooled up somewhere on the machine, so it is available. The other ones have been created, but at the moment they are not tooled up. So we select depth, and confirm. So these are the main parameters, but let's go back and select the top. We select again the same machining. Now let's say we want to create a boring line. We have a couple of options in order to do that. So like I was saying, if the coordinates from the reference corner are the same also for the other side, we can just simply select the two corners. And then, of course, again, the tool, if we want to go with the 5, or we can use whatever other tool we want. Depth, 10 or whatever it is. And here we can go directly on the repetition tab. On this field we can select different type of repetitions, and so based on what we need to do we can select the more appropriate. In this case I'm gonna use the linear. How many repetitions? It depends on what I want to do, so I can go just by a number. Or I can put a formula if I want basically the amount of repetitions to change according to the length of the panel. So in that case I will have to write in a parenthesis LPX minus 200, because I started from 100, and then if I want to keep, you know, the same distance on the opposite side, it will be another 100, and everything has to be divided by the gap, and normally is +1. Step 32. Or, of course, if I want to use a different step, just simply select 64 and remember to change it also here. In this case, since we have the formula, if we change the panel length, it will also change the amount of holes. Another function that can be helpful is the vertical step. So if we are working, I don't know, with a really hard material, or for any reason we want to split the depth in multiple passes, we can do that from here. So vertical step, how many? So if I want to go down 5 millimeter at a time, I just go 2. So I divided the 10 millimeter by 2. And when you are using the multipass, basically you can also select if you want the complete unloading of the chips between one pass to the other. So it will go down 5 millimeter and then it will go completely out of the panel to go back down for the second pass. Otherwise, partial, it will be going down 5 millimeter in this case, and then go up until the top of the panel, but it will not exit the panel. It will stay down, so of course it will save time. It will still be helpful, you know, to unload the chips, but you are gonna save time anyway because it's not completely going up. Otherwise, the third option is unload at user-defined position. So when you select this option, you are also able to select and specify how much the tool has to go back after reaching the first step of the depth. So, like for instance, we went down 5 millimeter for the first step. I want to go back maybe only 3. Then speed. Here everything is at 0, and in this case takes the default of the tool. So whatever is the default machining feed rate for the tool will be used. Otherwise you can change it directly here. As we can see, the feed rate, it is set for the default at 3 meters a minute, so 3000 millimeters a minute. And the rotation is 4000 RPM. These are the feeds and speeds that will be used in case we don't specify anything here. Otherwise, these fields will overwrite the standard. Safety, again, all these will be taken directly from the tool, and as we can see is 10 when we are using the jig safety, so the safety above the table, or will be 30 in case we are using clamps. But if you want to change for some reason, because I don't know, you are in a particular situation, you can always disable the standard and change it just for this program, or actually just for this machining. Piercing data. Piercing is basically the function that helps you avoid chipping the back of the panel when programming through holes. So normally for this function we prefer to use a conical bit, so with the sharp tip, and with these parameters you can control the feed rate. So piercing distance, it means that you can determine when the machine has to reduce the feed rate, and in this case I can say, I don't know, it's normally when you program this one will be of course 5 millimeter, and you will have to enable the through hole. So in this case it means that it will go 5 millimeter through. And we can say that for the last 7 millimeter of the depth, you need to change feed rate, and instead of using the default, which in this case is 3000 millimeters a minute, you need to use 800. And then confirm. Now, like I was saying, there are a couple of options to create a boring line. We have seen the one starting from the selection of two reference corners and using the linear repetition. But we can do the same thing, so cancel, let me leave it that one as it is. But we can do the same thing also with only one reference corner, so 100, 100, just to make it simple. Tool, 5mm, depth 10 or whatever it is, and then repetition. Instead of using the linear, we can use the matrix. So the matrix allows you to repeat in both directions, x and also y. So we are gonna say, again, if we want the amount of repetitions to change according to the size or the length of the panel, we can use our variables. Length of the panel along the x minus 200. Everything has to be divided by the gap. We have used 64 for the previous one, so let's still use 64 plus 1. Number of repetition in y, in this case, is fixed, is only 2. And we can change then the step for the x to match whatever we have used here, 64. And for the y, we can use length of the panel in y minus 200. Always if we want to keep the same distance from both sides, so front and back. Otherwise, of course, we can change it to 20 or 250 or whatever has to be. Or maybe less, 180. Confirm. We can compare. So, of course, on this side, there is a difference just because instead of using 100, so 200, considering 100 for each side, we have used 180. So on this side, of course, it was the starting point, so for sure it's gonna be 100, and the 80 will be here. But if we want to make sure is exactly the same, so in two different ways we have achieved the same result. I think we have touched all the basic parameters for the boring machining. On the next video we will see the sockets, so see you at the next video.